I'm starting to get the flu, leave me alone.
Well, no.
Okay. That is just gonna record me. It's for my class, so it's gonna. I just need a video of me teaching a lesson. So
It's not going to show you.
it's not. No, you won't be in the video. Maybe your voices, but that's it.
It's on this page.
Just start doing random quotes from the Big Bang Theory.
I love that show.
That's different.
Monday.
My dad wants to get their pajamas.
Pajamas.
Yeah, they're on geeky.net. That's legit the name of the website.
Getting them for Christmas this year.
Yeah. I hope I get what you call it, pellet gun I wanted for Christmas. Well, they were supposed to get me a bow, but they went from bow to handgun to pellet gun, and now I'm supposed to be taking out shooting machines so they can find out which caliber to get. Fun. When the snow clears up this spring and or summer, how long it lasts, Dad's gonna take me out to the range and I get to finally shoot. Probably. It's been 2 years since I've last shot a gun.
Whoa.
Yeah.
It's
Pretty
been,
bad.
well, that's less time than me. I really never shot a gun, so.
It's fun though. Where'd you shoot?
We're going to have to sit in the seat
I was out there.
behind where you
Okay,
just sit
so
because
we
the
were
sound
seeing
needs to be
I was able to
okay.
shoot really small targets from far away, but up close I couldn't shoot the big targets.
It's all yours, Miss Andy.
Alrighty, so let's start. So you guys have been practicing a lot with finding rules and tables and then making them into equations. Today I'm just going to sort of build on what you've been doing. We're going to go over a few problems in the book today. So in chapter 3, page 105, we're going to start on that page. Question 33. And you will need graph paper, so if anyone doesn't have any and needs to get some, you guys can do that right now. Everyone on the page has graph paper. I want to start with 33. It gives us a rule. Y equals 2x plus 1. And then it has an input-output table for us. Just gonna copy that. So once we have our inputs, I just want us to fill out the table first. And so I'll start from this end with -4 and plug into the equation, so that's -4 times 2 is -8, plus 1 is 9. And Jacob, you give me the next one to our table? What happens when we put -3 in 4? Oh, I'm sorry. I meant -8 plus 1 is -7. Okay. Now, when we put in -3, what do we get for our output?
7.
Right? But is it positive or negative? You put in -3 times 2,
-5.
and that's -6 plus 1. So that's -5, right? And then we'll just continue. So -2. Courtney, can you tell me what that one is? You got 0 for that one? You put a -2 in here? It's okay. Okay, so we're solving for these outputs, so we're just taking each one of the inputs here, and you want to put it into your equation y equals 2x plus 1. So if I were to put in -2x in here, so it's going to look like that, and then to solve for that equation is what we're doing. If you were to multiply it, you need to make sure there's parentheses around the negative sign. And when you add 1 to it, not 5. You have -4, there you go, -3. And then we put in -1, so that's -2 plus 1, which is Haley. -2 plus 1. When you add a positive to a negative number, you're going in the positive direction, right? So if you add 1 to -2, what do we get? Not quite. -2 plus, we're adding a positive 1. So you can think of it as, there you go. And 0, we just get 1, right? Because we multiply 2 by 0, it's 0 plus 1. Now the other direction, Alex, when we put in 1.
3.
Mandy, we put in 2. You said 5?
5.
Yep. 5, good. And Caleb,
7.
7 for 3. Then 4, we get 8 plus 1, which is 9. So now that we have our table, what I want to do is just look at the outputs really quick. Can somebody tell me the highest value that we have in this table?
9.
9.
Please excuse the interruption. Just want to make this one announcement. At the end of period 5, whether it's class or period 5 lunch, students need to report to homerooms, and we'll dismiss from homerooms to our assembly this afternoon. Thank you.
So right, our highest value is 9, and what was our lowest value?
-7.
-7. So we're going to now create a graph for it. And we want to keep in mind our highest and lowest values, because now we have to scale our graph in order to fit all of our values on there. And we want to find appropriate scales so that our graph's not too spread out or too close together. So what do you think would be, could we go by ones maybe for this one?
Yeah.
So let's see. So we're going up to -4 here. 4 here. looks like if we go by ones, we can fit them all comfortably onto this graph. And so now we're just going to start with our, from -4, -7. So if I graph it, I go over to -4. So that's left 4 from the origin. And then from -4, we're going to go down 7 places. So 1, 2, 3, 4, 5, 6, 7. And so our first point is right about there. And from the table, who can help me graphing -3 and -5? Jacob, how did you do that? Okay, so this direction 3 and then -5. Down 5. Right. And Courtney, how about -2? And down 3, right? And you're seeing a pattern happening. It's -1, maybe?
Over left 1 and then down.
Right. And we're seeing a pattern, so I'm just going to quickly 0, 1, and just quickly fill in our table. And then over 1, up 3. And then we had 2, and up 1, 2, 3, 4, 5. Over 3, up 2, 3, 4, 5, 6, 7. Our last point was over 4, then up 9. Okay. So this should be what our graph looks like for 2x plus 1. And I do not have a ruler, but if you want to take a straight edge and just connect those points. If you don't have a ruler, you're going to need one, sorry. That's our first graph. And once we have that one, I want to move on to 34. It's going to be similar. We're going to be graphing and finding a table again. And then we're going to look at the 2 graphs we just did. So on 34, we have a different equation. It's going to be y equals -3x plus 1. And then again, we're going to go through our system of finding outputs from the equation. Starts at -4 again. Okay. Now you guys have a few seconds to just draw that new table. And let's go about the same way we did the first one, and let's just solve for our outputs again. So starting at -4, we're gonna put that in for -3x plus 1. And again, what would we get? Haley, what would my first output be? 13. So yeah, -4 times -3 is 12 plus 1 is 13. Good. And Courtney, how about -3? 9. Oh. That's, you put negative 3 into x. The negative 3 times negative 3 is 9. Can't forget 1. And then, Mandy, how about negative 2? We put that into negative 2 times negative 3. Yeah, and then you add 1 to it. 7, right? Okay. And Caleb, negative 1.
5. Oh, I mean 4.
There you go. And Alex, how about zeros? Just
0.
we have that 1 there.
Oh, 1.
There you go. And Jacob, how about 1? There you go. Because that's negative. You add 1, but it's not going to be negative 4 if we add a positive to a negative value. Because 1, this is, now we have to remember we have a negative 3. So that's negative 3, and you add 1 to it. What's going to be? No, you'd be going in this direction. You can also think of it as 1 minus 3. And if you subtract 3 from a positive 1, what would you be left with? Yep. And Courtney, how about 2? For, you put 2 into, when you work with negatives, you need to remember the parentheses. If you're going to multiply, you put parentheses around your negative 3, and then multiply by the 2. It should give you negative 6. Yeah, you got negative 6, and you add 1 to negative 6. It's the same as 1 minus 6. Oh, wrong turn. There you go. And then we put 3 into our equation, Haley. Oh, careful. We have negative 3 times 3. So that's going to be, oh, I'm sorry. Did you say negative 8?
Yeah.
I'm sorry. You're right. And then 4 times negative 3, so it's negative 12 plus 1, so negative 11. And again, we're just going to make another graph for this. And looks like we have some bigger values than we did last time. What's our highest one this time? Jacob? 13. And our lowest value is be that negative 11. So that's going to be our, we need to now scale our y-axis to be able to fit those values. We have to go all the way from 13 to negative 11. So we're going to have to scale this graph a little differently this time. Not by much. So what would we think we could scale our y-axis by and fit those values? By 2? Does everyone agree? 2? So we could go 2, 4.
Should go to 11 so that we have an easier way to go.
I'm sorry?
Never mind. It's just me.
Well, we can try it out and see. And then our x-axis is going to be the same. Because they're still going from negative 4 and our inputs to 4. And now let's start start with graphing this one. So our first point was negative 4, 13. So you're going to have to go left 4, down 13. And remember we're going by 2s, so
Wouldn't you go up 13? It's positive.
Sorry, I was looking at that one. Negative 4, yeah, and we're going to go up 13. You're right. So it's going to go over 4, and now it's going to go up 13, but we're going by 2, so you have to be careful. 13 is going to be about in between the 12 and 14. And so, point's going to be right about there. Now I want to give you guys a few seconds to just finish that graph on your own, and we're going to see what it looks like. When you're done your graph, you're going to want to connect all the points just like we did last time. Does everyone have the graph finished? Do you want, now we can see, now we're going to see the difference between these two graphs. I can't flip them both. But you guys have both of your graphs in front of you. This is what our first one looked like. And our second one.
We're going in opposite directions.
They are. And why do you think they're going in opposite directions? What's different between the two equations?
Because the number before the x is positive, and then it's negative on the next one.
Right. So they have different slopes, in other words. So one has a negative slope, and the negative slope, this one, see it, negative 3, the negative slope actually makes the lines go downwards. And the 2x, the slope's going to make it go upwards because it's positive. So good. And so that is a difference here. And what's similar about them? Courtney, what's similar about the two graphs? They both have, right, they both have the same intercept. They both have the same y-intercept. And if you look at the two equations, you have that +1 there. You notice that? And then on your table, you see 0, 1. So if I were to bring up the table, this is the first table. You see 0 and 1 here. So when your input was 0, your output was 1. And then you notice it's the same here. So that's good. They both have the same intercept. That's because when you put 0 in for x in both equations, you're just left with 1. So that +1 is going to be your intercept. So if it were, let's say if this one was negative 3x plus 2, you'd notice that your intercept would change to a 2 instead of a 1. So right, they have the same intercept.
pretty much the same scale for left to right
Yeah, they're similar.
on the
Um,
x-axis.
Good. And they're both linear equations, right? You notice that their equations are both, I don't know if I can bring them both up here, but they have the same kind of form, right? It's always 2x, 3x, and then you add a constant, 1, or you subtract 1. So they're both linear graphs. So that's good. And we're now going to be working with a different type of graph. So if you turn the page, you're going to need more graph paper. We're going to try number 35, and we're going to see what this graph looks like. So on 35, and again we have an equation, but you're going to notice it's going to look different than the equations we've been working with. It has an exponent, this little 2 up here. You're going to notice that's going to change what our graph looks like. So again, we're going to make another table, just like on the book. Copy. Okay. So now, let's go about solving this one. So whenever you square a number, it's always that number times itself. So we want to keep that in mind when we solve for our outputs. So if I were to put in, for example, -4, we're going to do -4 times a -4, or -4 squared. And a negative times a negative is always going to be positive. The signs cancel each other out. So your first term is going to be 16. And now let's go out solving the rest of it. How about -3? Jacob, what happens when I square -3? If you put in your calculator, remember you need parentheses. You're going to open parentheses, and then -3, and then do your squared, your exponent. So it looks like that in your calculator. Good. Pause in that. And -2, Courtney? What do you get when you square -2? Yep. 4. Mandy, how about 1?
1.
Good. Haley, what about 1/2? What do we get when we multiply 1/2 by 1/2? You can do it on the calculator, just remember the parentheses. Or if you look at the fractions, 1/2 times 1/2. When we multiply fractions, we multiply straight across, right? So 1/2 times 1/2 is going to be, what would we get? 1/2 times 1/2. You multiply straight across with the fractions. So if I multiply straight across the top, 1 times 1 is 1. And then our denominator, 2 times 2, 4. So that value is going to be 1/4 when you square 1/2. And then 0 times 0 is always 0. And then Mandy, how about 1/2? Oh, if we look at this one,
1.
1/4. Now, as we keep going, you're going to see a different pattern going on. And then 1 times 1 is 1. 2 squared. 2 squared, Caleb? 4. Alex, how about 3 squared?
9,
9. And then again, 4 squared,
16.
16. So now we're seeing something different. What are you noticing about the table?
Staying exactly the same.
Right. From 0, but we have, as we go out, these values are the same. So let's graph it and see what it looks like. And our highest values
16.
is 16, and we just need the positive values for our y-axis. So I'm not going to worry about making the bottom half so much. Let's go by lines again. So that's 16 right there. So I'm going to set the graph like this. Not going to worry so much about this bottom half here. But I just did it by ones here, 16 spaces. We have enough to graph those two outside points. And then 16, and then we have -4 and 4. Okay. So our first point was -4, 16. And so to graph that, Jacob, where's that point going to be? Right. And this top line is 16. Good. And Courtney, how do we go at graphing -3? -3, 9. Yeah. I probably should have marked a few more points here. Okay. So over 3, and then just 9 here. And then -2, 4, Mandy?
Left, 2, and then out.
Yep. And Haley, how about our -1, 1?
Go over 1 and up 1.
Left 1 and up 1?
Yep.
Good. I have this little point here, -1/2. So if these are by ones, it's going to go 1/2. The 1/4 is just a little ways up. So right about here. And now you're noticing that it's not necessarily a line anymore. So let's keep going. So 0, 0. And then now they're going to look like the ones on the other side. So for 1/2 again. So -1/2 again is just going to go up to 1/4. So 1/4 of the way to 1. And then our 1 was 1. And then 2 is 4. 1, 2, 3, 4. 3 is -9. And 4 was 16. Now. Alright. So now. So what do we notice about this one? It's not a line anymore, it's like a U shape, right? It's a parabola. This is the new graph, it's called parabola. And parabolas are usually associated with this exponent of 2. If anything, if you see an x squared in your equation, you're going to know that your graph is going to look like this parabola or similar, depending on the slope of the parabola, which we'll get into. And you can connect all the points like this. And it's just going to go up. And these sides are just going to keep going. And you notice that it has one low point here. And parabolas can either go upwards like this one, or in your book, you see on page 106, it has one that faces downwards. and it depends, it's sort of like a linear equation. If it's negative, you're gonna see it's gonna face downwards, and since our slope's positive here, it's facing upwards. And this one little point here, it just happens to be 0, 0, but the vertex is what it's called, our lowest or highest point in the parabola. And you can notice that a vertex can be at any point on your graph, not just 0, 0. If I were to add 1 to this equation, kind of like our linear equations, it changes the intercept. So it'll move our graph up 1 space, and you'll see that the intercept will change, and the whole graph will shift upwards. So that is an introduction to the parabola. I just wanted you guys to see it, and notice that they're different from linear graphs. They have now exponents, and they're going to be U-shaped, and they have what's called a vertex. Just some basics about the parabola. And I have a little bit of homework for you guys that you can start right now, actually. I just had a few problems in your book. On page 106, you're going to see problem 36. And then on page 107, problem 37, they're both dealing with what we've been doing, which is filling in a table and making a graph to them. And just for fun, if you guys can just graph the negative equation to the parabola, just so you can see what it looks like and have practice with finding the outputs for a parabola. So creating a table and a graph just like the book. And so just these 3 problems, and you guys can get started on them. There's about 10 minutes left, and whatever you don't finish in class will just be homework.
Very good.